So we've drawn this on the back. It says 10.2 on Big Ideas due tomorrow. I see no reason for you to not finish it in class. Every single person in my last hour finished in class, so I foresee you doing that as well. But we're going to start with our notes. It says in the diagram, point S is a point of tangency. Find the radius of circle Q. So if S is the point of tangency, which of these is the tangent line? ST. So if this is my tangent line, which of these is my radius? QS. So then where's my right angle? Angle S. So we're going to use the Pythagorean theorem. A squared plus B squared equals C squared. Which of these will be A and B? 20 and R. And then C will be the full length of this hypotenuse. So what is the full length there? 10 plus R.
Maybe 10 M?
Meters.
Oh.
It's okay. It's early in the morning. M stands for meters. Good question. What is 20 squared? 400. Oof. So we have 400 plus R squared. When 10 plus R is being squared, we're going to write it twice. So we will distribute on that right side. So we're going to distribute the 10 first. 10 times 10 is 100. 10 times R, 10R. And then R times 10, 10R. And then R times R, R squared. What happens when I try to move either of the R squareds? They'll cancel out. So that'll go away. That'll go away. So I have 400 equals 100 plus, what's 10 plus 10? 20R. Subtract 100. 400 minus 100 is 300 equals 20R. So then R equals 15. Beautiful. So we don't have a quiz over this until we return from spring break. So I believe this is on page 5. So go ahead and flip to page 5 of your notes. We talked about arcs. There's a major arc, minor arc, and semicircle. How many degrees is a major arc?
180.
Yeah, anywhere from 180, well, not 181 to 359 technically. So between 180 and 360, a minor arc is less than 180, and then a semicircle is 180. Okay, it cuts the circle in half. We're going to identify it and then find the measure of each of them. So starting with TQ, that is 2 letters. So automatically, what do we know what it is? It's minor. So it needs to be less than 180. So I need to go the shortest route between T and Q. Am I going to go left around the circle or right around the circle? To the right. So how many degrees is TQ? 120. I'm going to go to number 2 next, QRT. So from Q, I want to go through R and end at T. So am I going to go left around the circle or right around the circle? To the left or to the right? To the right. I want to go through R and end at T. So you can add those 3 arcs. You could also, it's all of the circle except for how much? 120. So what could I do with that 120? Subtract from 360. So what is the measure of this one? 240, which makes it a major arc. Last is TQR. So starting at T, do I want to go to the right or to the left? To the right. Through Q and end at R. So how many degrees is that? 180, which makes it a semicircle. Beautiful. I'll erase so I have a room for the bottom. QS is 2 letters, so that one's going to be minor. We want to go the shortest route from Q to S. So I go, we could say up or down. Do you want to go up or down around the circle? Down. There are 2 ways to do this. You could find this arc and then add it with 60. You could also, how much is not a part of this arc? How much of the circle is not a part of this arc? Is 80 and 120, which is 200. So how much does this arc have to be? 160. So what we did was 80 and 120 is 200, which means there is 160 left for our arc. That's option 1. Option 2, you can take 360 and subtract 80 and 120 makes 200, plus another 60 makes 260. So what is the measure of this remaining arc? 100, and then you add them. That's fine too. Either way, you get 160. TS is a minor arc. Once again, what's the measure of arc TS? 80. Okay, 80. And then we have RST. So from R, we want to go through S and end at T. So that would be a semicircle. 180, a semicircle. Beautiful. I would say that people got tripped up today. I could show you before we move on. They were like, we were only given 1 degree. Let's say that this one was 60 degrees. You could technically find all the rest of them just by this one. Because how many diameters are in the circle I just drew? 2 of them. So that means how many degrees is this arc? 180. So then this piece has to be 120. How would I find the remaining vertical angles? So this one's vertical to this one, so it'd also be 120. This one's vertical to this one, which would be 60. So don't get tripped up by that question when you see it. You get 1 because you have a diameter. So, all right, your next page, we have another survey. Asked how many minutes they spend brushing their teeth. Whoever said 4 minutes, I hope that they mean like flossing included or mouthwash. 4 minutes is a little excessive. Do you know the right answer? Like what dentist? You probably know. It's 2 minutes. Okay. It's 2 minutes. So I'm lucky if my 1-year-old brushes for 15 seconds. So we try. Letter A. Find the measure of A, B, C. So from A, I want to go through B and end at C. So what am I going to do to find A, B, C? Add 82 plus 120, which is 202. That's okay. A, C, B. So am I going to go up or down around the circle? Up through C and end at B. So this is all of the circle except for 120. So what am I going to do with this? Subtract from 360. So 360 minus 120 is 240. Notice how the directions didn't say, tell me if it's major or minor. That's why we're not writing it. B, D. So I want to go from B and end at D. So that is 82 and 13. So what is 82 plus 13? 95. And then last is C, B, D. So starting at C, going through B, ending at D. I kind of highlighted it. So we use all of the circle except for what? 13. Except for 13. So we're going to do 360 minus 13. It's a terrible color. What do we get? 347. Good. All right. So I think from here we do a little more review. In circle E, tell whether arc ABC is congruent to arc ADC. Explain why or why not. So remember that 2 things, remember I made you like a checklist. 2 things had to happen. They had to either be from the same circle or congruent circles. That ensured the length was the same. And then they had to have congruent central angles. So we're looking for both of these to be true. So ABC, how many degrees is ABC? 180. Then we have ADC. How many degrees is ADC? 180. So we definitely have congruent central angles. Are they in the same or congruent circles? Yes, they're in the same circle. So this would be a yes. Explain why or why not. They're in the same circle. And you can say, and they have congruent central angles. You could also just say, and they're both 180 degrees. There's a little bit of flexibility on that part. You can be specific to the question or just use the same definition. Question on this one? Beautiful. The next page, we have two more. This one's new. We're going to find the value of x and then find the measure of AB. So we know AB is 5x, and we know that 40 degrees is BC. We know that CD is 70, and we also know that AD is 75 plus 2x. So is any part of the circle missing? No. So what do we know about all the arcs in the circle combined? They add 360. So we're going to add them and make them equal to 360. So 5x plus 40 plus 70 plus 75 plus 2x will equal 360. So combined like terms, we have 5x and 2x, which makes 7x. And then we have 40, 70, and 75, which makes 185. Subtract 185 on both sides. What is 360 minus 185? 175. Divide by 7, and x is 25. So it says find the value of x, but it also says find the measure of AB. What was the measure of arc AB when we started the problem? 5x. So then we're going to plug in x. So 5 times 25 is 125. Again, a variation you might see is if you're given a diameter like this, and, 7x plus 10 and 3x or something like that. Are you given the whole circle? No, you'd be given half. So what do you know about these two arcs? They add to 180. These are the only two variations you'll see. Just be prepared for both. And then last, tell whether the arcs are congruent. So remember your two things that you need. They either need to be from the same circle or congruent circles, and they need congruent central angles. So in number 7, they're not from the same circle, obviously. Are they from congruent circles? Yes. How do I know these circles are congruent? The congruent marks for the radiuses, radii. All right, and then do they have congruent central angles? Yes. This is a yes. We could say they're in congruent circles. And they both are 145 degrees. It's kind of a way to shorten it. You could say they have congruent central angles also. Both are fine. Number 8, these arcs are not in the same circle. Are they in congruent circles? No. How do I know they're not congruent? Right. 5 and 4, their radii are not the same. So no, because the circles aren't congruent. Oop.